Okay, so let's look. So getting started on this. First thing we need to do is just identify the asymptote. And that is the boundary line that the graph approaches. But never touches. Range, and I want you to let's talk about the domain and range of what the parent function is. Now, don't put range underneath domain, and you'll see why here in a minute. I want you to go domain, vertical asymptote, range, horizontal asymptote. Now, the nice thing about this unit is the domain is always going to start off with this right here, and so is the range. So for the rest of this unit, whenever you see domain and range, you don't even really have to look at the equation on that problem. That's it right there. Okay. So next we need to identify the vertical asymptote, which on this problem right here is right there. And so what is the equation for that line? X equals 0. And now let's talk about this, because we have to kind of include that into the domain in a way. So again, domain measures left to right. So that goes to negative, that goes to positive. But it curves up, and remember, it never touches 0. It's never actually equal to 0. That's the one value that it's never equal to. So you have to include that in your domain. Okay, if we do not put that, then your domain says that it does equal to 0. Had someone last class ask, do you always have to put that? Yes. Okay, that's probably not going to be a partial credit thing. That's a full credit. All right, you've got to be able to identify what those are. Your horizontal asymptote in your range, it's the same idea with that. So what is the equation for that line right there? Y equals 0. So you'll put that y does not equal 0 on that. Later we will find that a lot of the stuff that we've talked about that were vertical asymptotes, that were excluded values, we're going to get to the point where we're going to kind of identify that as vertical asymptotes, and then they can also be something else. Okay? So, let's come down here and make sure that we're still good on these transformations. So, plus C moves the graph which direction?
Right.
Left. Remember, the C is left and right opposite the sign. Okay, now on this, don't just put left, because, again, I want you to think about the asymptotes moving. So put that it shifts the vertical asymptote left. Minus C shifts vertical asymptote to the right. If it is plus D, which direction is that going to move it? Which direction? Up. So on that, I want you to put shifts horizontal asymptote up. And minus D shifts the horizontal asymptote down. If A is greater than 1, what does that do to the graph? Vertically what? Vertically stretches. If it's between 0 and 1, it vertically what? Compresses. and I forget which unit it was. It might have been quadratic. We had the B value where that did the horizontal stretch and compress, and you had to do it by the reciprocal of whatever was in the equation. That was the one that, was a little bit more confusing than the A value. We don't have to do the B value on this stuff. Okay, that's something that y'all will probably come to appreciate in here. We don't deal with the B value as much as y'all did in pre-AP. So, the negative, how does that affect the graph? Reflects over the x-axis. So, make sure that, again, you're familiar with those. It's been a while since we've gone through those, but I feel like we've already talked through all those probably 3 or 4 times already this year, just with different functions. So, with all that, let's go down and go through these and just identify what transformations are in those equations. So, number 1, Isaac, what would that be? If you have an A value of 3/4. Is 3/4 bigger than 1? Vertically compressed by 3/4. Morgan, number 2. Right 5. Joe, number 3. What's that negative going to do? Reflect over x-axis. Olivia, 4. And we'll skip 5 for right now because we're going to make a point on that.
Does it matter that 2?
On what?
Like 4 and 2.
It does not matter.
Okay.
And then Garrett, number 6.
Left 3.
Okay. And Ty, if you were to guess on number 5, what do you think that 2 is going to do?
Vertical stretch.
Vertical stretch. Okay. Know that, and I want you to write this the other way. That is the same, and you'll most likely see it the way it's typed on there. That is the same as that right there.
Question.
So if you have that numerator and it's something other than 1, that's your A value. Okay? So we said vertical stretch by 2. These are problems that have multiple transformations. So looking at number 1, Andy, what is one of the transformations that's on there?
Left 3.
Lily, what's the other one?
Down 4.
On number 2, Bree, give me a transformation that's on there. Marshall, give me another one.
Of 8.
And Carrie, what's the last one?
Right 2.
Going to number 3, Trey, give me a transformation that's on there.
Up 2.
Aaron, give me another one.
Right 8.
Chance, another one.
Reflection.
Flux over x-axis. And Ryan, what's the last one?
Vertical stretch by 3.
Awesome. Okay, make sure that you know and start drawing this correlation, because this is a lot of units. Whenever we talk about transformations, you just kind of had to know what we just put up there. But I want you to start connecting that left 3, that's giving you a vertical asymptote of x equals -3. And some of you were saying that whenever I was asking for the transformations, which is good. Your horizontal, you're down 4, which I didn't put 4. That's your horizontal asymptote. Y equals -4. Okay, so start kind of connecting those two, and that's really going to help you graph it. Those, especially right now, those are the main things that I'm concerned about you locating on the graph. And those are things that are not going to show up on your calculator. Okay, you're just going to get the curved lines on your calculator. So, going down to the last 2 problems. So this is just the opposite of what the previous problems were. They give us the transformations and they want the equation. Okay, so if I have this and this equation goes left 2 units, Mr. Hall, what is going to be my denominator?
It will be x plus
x plus 2.
2.
Anissa, if it goes up 4,
Plus 4. Wouldn't it be -2?
no, it goes opposite. So plus will go to the left.
Oh.
Minus will go to the right. Olivia, what needs to go at the front?
-3.
-3. Vertical stretch by 3, and it's negative. So is that the same as that?
Yes.
Yes. Is that the same as that? Yes. Okay, so kind of 3 different ways, and probably the most likely way that you'll see it, probably that way, maybe that one. It's very unlikely that you'll be given a problem like this, where you'll be asked for the transformations, and it looks like that. If you have a problem like this, where you're given the transformations and you're writing the equation, and you put that is absolutely correct. So are the other 2. Okay, so make sure that you know that, because if you notice, whenever we started writing that, if it's one of these kind of problems, I would just start right there and just add it in piece by piece. So going to the last one. If this goes to the left 8, Zach, what needs to go in the denominator?
X plus 8.
Gracie, if it goes down 2.
-2.
And Marshall, what needs to go in front? 1/2. How you'll see a lot of these is this.